Here is the introduction for our topics. Electricity and magnetism are fundamental aspects of physics that describe the behavior of charged particles and their interactions. These two phenomena are deeply interconnected and are studied together under the branch of physics known as electromagnetism. I will be explaining about the key concepts here. The first one, we have the electric charge and electric field. Electric charge is a fundamental property of matter, and an electric field is a region around a charged particle where an electric force is exerted on other charged particles. For the second one, we have magnetic field. Magnetic field is a region around a magnetic material or moving electric charge within which the force of magnetism acts. For the third one, we have electromagnetic induction. Electromagnetic induction is the process by which a changing magnetic field generates an electric field, as described by Faraday's law. Now I'll be explaining about significance of electricity and magnetism in electrical transportation. The first one, we have magnetic levitation, or we call it as maglev. It is a high-speed transportation. Magnetism is the basis of maglev trains, where magnetic forces lift and propel the train, eliminating frictions with tracks. This results in high-speed, energy-efficient travel. Stability and control. Advanced electromagnetic systems are used to stabilize and control the train's motion. Second one, we have energy generation and supply and electric power sources. Electricity generated from renewable or non-renewable sources is the primary energy carrier for electric transportation systems. Power plants, solar panels, or wind turbines supply the electricity required to run vehicles like electric trains, buses, and cars. Transmission efficiency. The principles of electromagnetism ensure the efficient transmission of electricity from power generation sites to transportation infrastructure through high voltage lines. We have the third one, which is regenerative braking. Energy recovery. Electromagnetic braking systems used in EVs and trains convert kinetic energy back into electrical energy during braking, improving energy efficiency. Magnetism in action. The system relies on electromagnetic induction to generate electricity as the vehicle slows down.
Electricity, the flow of electrical charge or power that can be either static or dynamic. Electric field can exert forces on stationary charges causing them to move. There are electric monopoles, such as electrons and protons, meaning that isolated positive or negative charge can exist. Magnetism, a force that generates electricity that magnets exert when they attract or repel each other. Magnetic fields exhibit attraction or repulsion based on the orientation of their poles, like poles repel, opposite poles attract. Importantly, there are no magnetic monopoles. Every magnet has both a north and a south pole. Component involved in electric vehicle power inverter convert the DC from the traction battery into alternating current to drive the electric traction motor. They also convert AC back to DC during regenerative braking to recharge the battery. Converts the DC from the traction battery into alternating current to drive the electric traction motor. It also converts AC back to DC during regenerative braking to recharge the battery. Next, we have electric traction motor converts electrical energy into mechanical energy to drive the vehicle wheels. Some designs include motor generators can also perform regenerative braking. Next, we have DC-DC convert. Converts high voltage DC power from the traction battery to lower voltage DC power needed from running vehicle accessories like lights, infotainment systems, and recharging auxiliary batteries. Auxiliary batteries power non-driving accessories like lights, air conditioning, and infotainment systems. These are the example of real-world implementation. First, we have BMW i series. Next, Tesla Y model and BYD. And the last one is Kia EV6. There are a lot more examples.
So, for the exploration of technology, for the first point is autonomous vehicles, that also known as AV. AV is able to detect objects on the road, other cars, and the roadway itself. With their sensor and AI, AV may fully utilize a technique called patterning, which significantly reduce the gap between vehicles. By sticking closely together allows the vehicles to take use of each other's slipstreams, which lowers air resistance and boosts efficiency. Additionally, platooning could allow more vehicles that travel on current roadways without creating traffic jams. So for the second point is safety system. Safety systems in electrical transportation are essential for ensuring reliability and user confidence to use EV. This system also focus on protecting passengers. For the example, we use advanced driving assistance system to monitor safety issues, including emergency braking, collision prevention, and driving assistance. So for the last point is battery. We use lithium ion batteries because they have high energy density and long lifespans. Lithium ion batteries also have a high power capability. So I will explain to you guys how do lithium ion batteries work. Lithium ion batteries work by moving lithium ion between two electrodes, which is anode and cathode, through an electrolyte. During charging, lithium ions are stored in anode, which is the negative electrodes. When the battery discharges, the lithium ions move to the cathode, which is the positive electrode, to release the energy. The movement of lithium ions is facilitated by a separator, which prevents direct contact between the electrodes. This process repeats during charging and discharging cycles that allow the battery to store and release energy. So, for the potential benefits of electrical transportation, for the first point is environmental benefit. It can reduce greenhouse gases. For the example, electric vehicle that also known as EVs can produce zero tailpipe emission. Tailpipe emission are the product of fuel combustion, for example like a gasoline. Then, over their lifetime, EVs can emit approximately 50% fewer greenhouse gases than equivalent internal combustion engine vehicles, even when accounting for emissions from electricity generation and vehicle manufacturing. So, for the second point of potential benefits of electrical transportation is cost saving. It can reduce maintenance. For the example, EVs have fewer moving parts and not require oil changes, fuel filters, or exhaust system. Then, service for electrical vehicles is around 30% cheaper than with a petrol vehicles. Then, for the last point of potential benefits of electrical transportation is smooth and quiet operation. Electric motors produce less noise and vibration, which makes EVs run much more smoothly and silently than traditional cars. As a result, driving can become more enjoyable and comfortable. Then, it can give a benefit to the human. For example, it can improve our mental health, especially in urban areas where traffic noise is constant irritant.
Potential challenge of electric car. First, we have limited charging infrastructure. The availability of charging station is still insufficient in many regions, particularly in rural area. While investments are being made to expand this infrastructure, it is not yet universal. The impact is a lack of accessible charging station makes it difficult for potential EV owners to feel confident about using electric car for everyday travel. Next, we have limited driving range. Range anxiety, which could be defined as when any potential buyers are concerned about the limited range of electric cars compared to gasoline vehicles. This fear of running out of battery power before reaching a charging station is known as range anxiety. And the last one is difficulty finding a technician. The majority of car owners discover that choosing a qualified independent maintenance and repair company can be substantially less expensive than having their vehicle serviced by a dealer.
Future developments and innovations in electrical transportation. The first one, we have longer battery life and reduced cost. Continuous improvements in battery chemistry and manufacturing processes are expected to lower the cost of batteries, making EVs more affordable and increasing their market share. The second one, we have ultra-fast charging stations. The development of high power charging (HPC) stations capable of delivering up to 350 kilowatts will make long-distance travel more convenient for EV users. These stations can charge an EV in a matter of minutes, comparable to refueling a gasoline car. Third one, we have flying EVs. These vehicles offer a new dimension of urban mobility, potentially shortening travel times in congested cities. They are being developed to provide efficient and eco-friendly transportation solutions for urban areas. The fourth one, we have hydrogen fuel cell EVs. These vehicles use hydrogen fuel cells to generate electricity, emitting only water vapor as a byproduct. They hold promise for long-haul transportation and could complement battery-powered EVs in the future.
So, for the conclusion, technological in electrical transportation make the transportation more accessibility, efficiency, and innovation. Electric vehicles, that also known as an EV, are powered by electricity and magnetism that offer a cleaner alternative to fossil fuels. For example, we can reducing emissions and driving in renewable energy like batteries so that it can improve our air quality and economic growth and make our future more sustainable.